You're given a motion diagram, and what we want to find is the kinematic stack that matches it. So at t equals 0, we start off at the origin, and then 1 second, at 1 second we're at 1 meter. These are seconds right here. At 1 second we're at 1 meter. At 2 seconds we're at 4, and at 3 seconds we're at 9, then 15, then 21 seconds, or 21 meters at 5 seconds. So I think the first one to draw would be the position versus time graph. And we'll go 1, 2, 3, 4, 5. And then this is going to go from 0 to 21. So I'll go 10, 20, and then I'll go, and then 5, 10. This is time in seconds. This is position in meters. And so at 0, we're at 0. At 1, we're at 1. And you have that classic kind of parabola starting to show up already, because at 2, it's 4. So here's 4 right here. And then at 3 seconds, we're at 9. So here's 9. And so we've got this curve like that. Then at 4 seconds, we're at 15. And then at 5 seconds, we're at 21. This gives me a straight line. Now this should be a little smoother. This should be the straight line part. Looks something like that. And this is easy. If I give you a motion diagram, this part's easy because it's just like plotting the time and the positions that are given in the picture. Everybody happy with that? Now we're going to do velocity, and our velocities are all positive. I can see that, so I'm just going to draw velocity. And I'm going to go 1, 2, 3, 4, 5. And notice how I'm drawing the time axis here directly below, scaled the same way. Now here the velocity is, if I look at the slope right here, and this dot, looks like the velocity is going to start off being 0. But we have a change at 3 seconds. I didn't plot that very well, but okay. At 3 seconds, I can see right here that, I went from 9 to 15, from 15 to 21. That's 6 meters in a second, 6 meters in a second. So my velocity is going to go to 6 meters. So I'll go, 1, 2, 3, 4, 5, 6, 2, 4, 6. And this is velocity in meters per second. So label the axis and so on. So at 3, I can just say, well, from here on out, the velocity is a constant. And then you can say, well, this class is what's the name of this unit? Constant acceleration. So you could just say, oh, well, that's going to be a straight line. Now I suppose I could try to draw tangent lines to prove that, but I'm not going to. You could, though, say, well, look, at 1 second, this should be 2. So what's the area of that? Well, 1 times 2 meters per second is 2 meters, but you cut it in half because it's just it's 1 meter. At 1 second, I was at 1 meter. 1 second, 1 meter. Now I can draw the acceleration versus time graph. Well, I'll start with the look at the slope here. Each second, the velocity is increasing by 2. So in 1 second, we go up from 2 to 4. In 1 second, we go from 4 to 6. So that means we're increasing our velocity by 2 meters per second every second. So my acceleration is 2 meters per second. Here, my velocity is constant. My rate of change of position is constant, which means my velocity is constant, which means my acceleration is 0. Oh, was I off screen for most of that? Okay, I probably can't use this video now, so please tell me if I'm off screen. Just say off screen, that's all you got to say, and then so anyway. And now I want to show you something else here. What was my change in velocity? Here I went from 0 to 6 meters per second. So my change in velocity was 6 meters per second. And look, 2 times 3. Look at the area underneath here. That's my delta V. Or, I'm sorry, 6. Now look at the slope of this line. The slope of this line is 2 over 1. So the slope gives me what the acceleration is. The area underneath the acceleration gives me what my change in velocity was. And then look at this. What's the area underneath this graph? Well, here we have 2 times 6 is 12 meters. And then the triangle is 3 times 6 is 18 divided by 2 is 9 meters. 12 plus 9 is 21. You can say, well, at 3 seconds, we were at 9 meters. 3 seconds at 9 meters, and that's that. So this was, so our change in position was 21 meters. Now we call it the change in, but look, our initial position was 0, so our change in position was still 21. So one of the skills I want you to know before we take our next exam, which is probably week after next, is to be able to go from here to here, to here, to here, or like I could give you any one of these and you could derive the other things. And if you can do that, then you really show me you understand the relationship between acceleration, velocity, position, displacement, what the slopes are meaning, what the area under the graphs are meaning. By the way, what's the area underneath the position versus time graph? Nothing. It doesn't mean anything. It has no physical meaning. Okay, that is all.